Hello everyone, welcome back to my YouTube channel. So now I'm going to solve question number 2 of weekly contest 482, minimum cost to acquire required items. And these are the constants. So cost 1, cost 2, cost both is from 1 to 10 to the power 6, right? So these three things given to us and these two, need 1 and need 2, right? So need 1 and need 2 constants is also very large, 0 to 10 to the power 9, right? Okay, so let's read the problem statement. So very good problem actually, very interesting and good problem. Okay, so you are given five integers, cost 1, cost 2, cost both, need 1 and need 2, right? There are three types of items available: type 1, type 2, type 3. An item of type 1 costs cost 1 and contributes 1 unit to the type 1 requirement only. Contribute 1 unit to the type 1 requirement only. Okay, so these are needs given to us of type 1 and type 2. Okay, an item of type 2 costs cost 2 and contributes 1 unit to the type 2 requirement only, right? An item of type 3 cost both and it contributes 1 unit to both type 1 and type 2 requirements, right? So type 1, right? So cost of 1 and it require it satisfies what? The type 1 requirement only, right? Same way type 2 cost 2 and contributes 1 unit to type 2, but type 3 it satisfies both type 1 and type 2, right? Contributes 1 unit to both type 1 and type 2 requirements, right? Okay, you must collect enough items so that the total contribution toward type 1 is at least need 1, right? Total contribution, right? It should be at least the need 1, and the total contribution toward type 2 is also at least need 2, right? That much we need to collect, right? We have to return an integer representing the minimum possible total cost to achieve these requirements, right? So here let's understand this with an example here, right? So need 1 is 3, so type 1 type 1 is going to contribute 1 to this, right? Same way type 2 is contributing 1 to this one, right? And your type 3 is contributing 1 unit to here and 1 unit to here, right? So we have to do these contributions until my need 1 becomes at least equal to 3 and my need 2 becomes at least equal to 2, right? Until then we have to contribute, and all these are contributing just one unit, one unit. Type 1 is just contributing 1 unit to this, type 2 is just contributing 1 unit to this, right? And type 3 is contributing 1 unit to this and 1 unit to this, like this. Okay, right? Clear? And these are costs given to us. So for type 1 this is going to be the cost, for type 2 this is going to be the cost, for type 3 this is going to be the cost, right? Okay, so here need 1 it needs 3, right? And it needs 2, right? It needs 3, it needs 2, right? Okay, now among these two, right, definitely let's say I need uh, two cricket players here. Okay, I need two cricket players here. Okay, and here I need three cricket players, let's say, right? So in both sides if I pick 1 2, and I can also pick 1 2 here, right? I can pick 2 here, I can also pick 2 here, right? This is the common, right? Only one extra is here, right? So minimum among these two is nothing but 2, right? Minimum among these values 2, right? So 2 is the common, right? We need 2 units, right? We need at least 2 units, right, to satisfy one of them, right? To satisfy one of them, right? So what I can do here, I have multiple options right here. I can maybe for these two players, right? Maybe I plan to spend this cost 1, right? For two players, right? So cost 1, tell me, cost 1 for two players I'm using. So 3 into 2 is 6. Same way, I plan to use cost 2 for two players. So I will get 4. So for satisfying these two players, the total cost I'm getting here is 10 as of now, right? But but for these two players, right? So I can simply use this cost both also, right? Because cost both is satisfying both the players, right? So cost both is for two players I need to satisfy, right? So cost both into two players, so I will get 1 into 2. So tell me, among these and among these, what is the best? Best is cost both 2, right? As of now, cost both 2 is best, right? See, cost 1 is giving first, right here, if you see, an item of type 1, cost 1, right, and contributes 1 unit to type 1 requirement only. So first 1 unit for one player, then 1 unit to other player. So two players are satisfied. Here 1 player for type 2 requirement, 1 unit for type 2 requirement, again 1 unit for type 2 requirement, right? So 2 here, right? So both the players are satisfying if I'm doing individually, right? Individually. So here cost is 3, here this cost is nothing but 2, okay? And here it satisfies cost both, it satisfies both. First, let's say first player, right, for type 1 and first player of type 2 which needs type 2 requirement, right? Let's say it satisfies this and it satisfies this. Then again it can satisfy this with and this, so both with the same unit every time, right? With just one it is going to satisfy one from here, one from here. With just one cost it is going to satisfy one from here, one from here. So that is why here also I'm writing 1 into 2, right? So here if you see, this two and this two, everything is common, right? Everything is common here. Now my answer is dependent on this factor, okay? 3, 2 and 1, right? Clear? Here this is nothing but for type 1. Type 1, two players are there in type 1, type 1, right? Two players are in type 2 and type 2, right? Type 1 and type 1, there are two players, right? 1 and 2. In type 2 also two players. And here this 2 means, 1 means type 1 type 2 and other one means one more type 1 type 2. So this 2 is common, right, everywhere. But now everything is dependent on this, right? So now here, see here, right? So I can plan to use these two costs, that's nothing but 3 plus 2, or I can plan to use this cost, right? So definitely I need minimum possible total cost, right? So definitely I'm going to use this one only, the minimum value, right? 3 plus 2, cost 1 plus cost 2, right? And here 1. So tell me which one is minimum, right? So I can say if my cost both is less than the cost of 1 plus cost of 2, right? In that case plan to use cost both, right? If it is both are same, then your choice, you can use cost both or maybe cost 1 and cost 2 individually, right? Okay, so if both are same you can use anyone, but if cost both is smaller than cost 1 plus cost 2 sum, right? From here, from this example it is clear, then use the best. So then I will use cost both, right, if this is the case. So right now this is the case, right? So I will use cost both, okay? So Now two players are satisfied, right? Two players are satisfied here, two players are satisfied here with cost both, right? So 1 into 2 I have spent as of now, total cost, right? Now remaining player is this one. This one is the remaining player. Okay. So here need 2 is already becoming 0, right? Need 2 is already becoming 0. Here need 1 is going to become 1 now, remaining, right? So this is already satisfied, right? We need at least. Now I want to satisfy this one player, right? So here again I have two choices. I can plan to use the cost one, right, for this one player. So cost one is 3, right? Cost one is 3, and for one player only satisfy, I need to just satisfy one player, so I will have to spend 3 here. Or I can use cost both also. So cost both, I do cost both, right? This need to is already satisfied. So cost both means one cost I need to spend, right? One cost I need to spend, right? So one here for just one player, 1 into 1. So I will get 1, right? So cost both actually it is going to give uh, one unit to this type 1, right? And it is also giving 1 unit to type 2. But type 2 is already satisfied, no problem, no problem. It is problem saying at least it can be more than that, right? But now my type 1 is also satisfied, right? So among these two, which one I will use? I will definitely pick the this one, because here I'm getting 1. So this part is same again. So here also again I need to find the minimum of cost 1 and cost both, right? Again, so whatever the minimum, I will use this for the remaining part, and I will satisfy the remaining players. That's it. So this is what I need to do, right? This is what I need to do. Very easy problem. Okay, code is also going to be very small, nothing complex here. See this example. Now I will just do it shortcut manner. Okay, need 1 and need 2. Tell me, here we have 2 players. Okay, here we have 2 players, here we have 3 players. So 2 is common among them. Minimum is 2, right? Minimum is 2. Minimum is 2, right? Now for these two, right, I have to see which cost should I use. So here if you see, cost both is 15. 15 is less than, tell me, 5 plus 4. No, no. Cost 1 plus cost 2, it's not, right? So definitely I'm not going to use cost both for my common players. 2 players from here, 2 players here from here, I will not use, right? So that simply means still remaining is 2 here and still remaining is 3 here. Okay, all right. So this is the first step that I need to check, step 1. Now step 2 is nothing but the pending players. So here again 2 players are pending, right, which needs type 1. So maybe I can plan to use this 5, or maybe I can plan to use 15. So 5 for 2 players, I will get 10, and cost both for 2 players, right? I will get what? I will get 30, right? So among them again I actually need to just compare these two, 5 and 15, which one is minimum? 5. So 5 use for 2 players, so 5 into 2. Same way 4 and 15, which is minimum? 4. So use 4 for 3 players. So here 12, here 10, you are going to get 22. That's it. Okay, okay, that's it, right? So that's it. Okay, that's it. So here this is what we need to do. Very simple. Here one good thing for this example, both need 1 and need 2 0, right? So we are just going to, if this is the case now, we are just going to return 0 since no items are required. Requirements is 0 for any player. We buy nothing and pay 0, right? But here for this player, two units of requirements are there. For this player, 3 units of requirements are there, right? So we try to check the cost both, if we can satisfy two players from both sides with the cost both, if that is possible. But it's not possible, then for the remaining players we have to check individually, right? So this is the code, very simple. Okay, so long cost is equal to 0 initially, then we have to going to do the pair as much as beneficial. So pair is nothing but the minimum of this need 1 and need 2, right? Now after that I will check if cost both is less than my cost 1 and cost 2. If both are same na, less than equal to, then you can use any one actually, right? You can use cost both also, or cost 1 plus cost 2. Okay, no problem. So here I will just use cost both when it is going to be smaller than this. Okay, you can also use this less than equal to in your code if you want to use cost both here, right? Okay, so I will check this now. Now here, if this is the case, then I will update my cost as, okay, cost as what. So here you can skip this if you don't want to write plus, because initially there is no value of cost, right? So cost is nothing but cost is equal to, you can give pair into cost both, right? Pair into cost both, right? Pair into cost both. So pair is nothing but the minimum value among this, and cost both is nothing but the, if it is smaller, then for those two players, right? So here if two players, here if three players, so for these two I will use the cost both if cost both is less, right? Then from need one I will subtract, right? So total pairs 2, and pair, in pair also I use 2, so remaining is 0, and here remaining is 1, right? This is what I'm updating. So pair as much as beneficial, this is going to be the first step. Okay, done. Now step 2 is nothing but a remaining of type 1, right? Remaining type 1. So here again I told you minimum of cost 1 and cost both, and just multiply it with the need 1, right? So you are going to get the cost. Same way remaining of type 2 is nothing but the minimum of these two, multiply it with the need 2, you will get the cost. And in the end you have to simply return the cost. That's it. So this is your code, right? Very simple, very simple problem, right? Okay, and what is going to be the time complexity for this one? So we are just going to do simple math operations, right? So you can say of 1 is the time complexity. That's it. That's it. Okay, simple maths operation, minimum and all among two values, and then check if this condition is satisfied, then just do this here for remaining, and that's it. Okay, so of 1 is the time complexity for this problem. Okay, so I hope that you guys are clear with question number 2 of weekly contest. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. We'll see you in the next video. Thank you. Bye bye.